Now we're going to learn how to make a box plot. The first thing we need to do is take the data and put it in order from smallest to largest. This data represents the score of 4th grade girls on an agility test. The score represents the number of times they can jump from side to side across a set of parallel lines in 30 seconds. So we see our lowest value is 12, and then we have 16. And I think I'm going to actually pause the video and you go ahead and write these in order, and I'll write them in order. Here are the data listed in order. The first thing we're going to do now is find the middle value. So there are 14, so if I count over 1, 2, 3, 4, 5, 6, 7, the middle two are 22 and 24, so 23 is our median. So there's the median. Now we've divided the data in half. We're going to look at the left half of the data and find the middle number, or the average of the two middle numbers. In this case, there is a single middle number, 20. We're going to call that Q1, quartile 1. The middle of the right side of the data is 25, so we're going to call that Q3. 28 is our maximum value, and 12 is our minimum value. This is known as the 5-number summary of the data. Now we're going to use the 5-number summary to draw a box plot. We need to have a horizontal scale going from 12 to 28. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And I'm going to go ahead and label every other one so I have some reference when I'm drawing the box plot. 2, 24, 26, 28. Okay, I'm going to make 3 vertical lines to represent Q1 and the median in Q3. So one at 20, one at 23, and one at 25. Okay, so here's Q3, here's the median, here is Q1. This is the center of the box plot. Notice that this encompasses the middle 50% of the data in this box. Now I need to add the whiskers, or what are called the whiskers that stick out for the 12 and the 28. However, I have to first determine if any of these numbers are outliers. So first of all, I'm going to compute what's called the IQR, the interquartile range, which is Q3 minus Q1. So 25 minus 20 gives me 5. Then low outliers are any numbers that are 1.5 IQRs below Q1. And high outliers are any numbers that are above 1.5 IQRs above Q3. So Q1 is 20. 20 minus 1.5 times 5 gives me 20 minus 7.5, which is 12.5. Then I have 25 plus 1.5 times 5, so 25 plus 7.5. That gives me 32.5. So anything greater than 32.5 or less than 12.5 is an outlier. Now there is some judgment call involved there. For example, if you had a value that was really close to 12.5 and it was really close to a lot of other data values, you might say it's not an outlier. Or if you had a number that was maybe something maybe 11 point or maybe like 13, but it was really far away, you could say, so this is kind of a rule of thumb, but that is what you're expected to calculate and show a calculation for to check for outliers if you see this as a question on a test. So we also want to always label our graphs, so we're going to label this agility scores. Okay, so that means that 12 is less than 12.5, so it's considered an outlier. So I'm going to mark it with an asterisk. Then I'm going to extend my box out to the next lowest value, which is the 16, and it ends there. There aren't any high outliers because nothing's bigger than 32.5, so I'm going to extend my box out to 28, which is the maximum value, and there's my box plot. Now something to recognize then is that each quarter of the box plot represents 25% of the data. So there's 25% of the data between 20 and 23. another 25% between 23 and 25, another 25% between 25 and 28, and the other 25% is much more spread out. The lower 25 is spread out between 12 and 20. So 25% of the data is contained in there. So notice we're talking about counts, how many data values. So there should be about an equal number of data values in each of these. Now obviously if I have 14, that's not divisible by 4, so it's not exactly 25%, but it should be pretty close. Now using this outlier rule, which Colts salaries would be considered outliers? So if we go back to the Colts data, let's take a look at that. So what we would want to do is looking at we want to find the IQR. So the IQR, remember, would be Q3, which is 2,270,833.50 minus Q1, which is 540,000. That's the IQR. And then we're going to check for Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. Now I'm just going to do this on the calculator because these numbers are pretty big and nasty. So let's just check this out and see if we have any outliers. And let's see here, just open up a calculator page here. Okay, so looking at this, I have, first of all, the IQR is 2270833.5 minus 540,000. Okay, so there's my IQR, fairly large number. Okay, so then I'm going to take my Q1 minus the IQR, so 540,000 minus 1.5 times this number. Okay, that's negative 2 million. Okay, so obviously we don't have any low outliers because I don't have anybody who has a salary of negative 2 million. Then I'm going to take the Q3, which is 2270833.5 plus 1.5 times the IQR. And there's the IQR. And that is 4.8 million. Now we do have a number of salaries that are bigger than 4.8 million. So if I go to my Colts data, equals 4.8 million. So 4.8 million is kind of in this general area right in here. So maybe any of these values here would be considered outliers. So there are quite a few outliers. And as a matter of fact, if we were to look at a box plot of this, you would see a very compact box plot here from here to here, and then a bunch of outliers over to the side. How would we describe the box plot? Actually, I think I'm going to leave that for the next video.